Hello, all of you. Please let me know if my voice is audible. Okay, so Atif, Huzefa, and Mazia, do you have completed the homework? Relation and functions, first assignment. Okay, Mazia, any doubt? I guess the assignment was simple, but anyone have a doubt in that? Okay, Mazia, very good. Huzefa and Atif, you have completed the assignments? Please reply yes or no. You didn't submit. Huzefa, please submit it, okay? Atif, you have completed the assignment? Atif, yes or no? Okay, please reply me on the chat box. Okay, in last class, we have started the equivalence relation. So I hope everyone is okay. I need to take a vibe of 1 minute. Okay, so Mazia, please, can you tell me what is the equivalence relation? I'm not sure you were present in the class or not. Can you tell me what is the equivalence relation? Okay, you were disconnected. Okay, Josefa, can you tell me what is the equivalence relation? Reflexive, symmetric, and transitive. Very good. So I guess we have started some questions based on equivalence relation, and we might have completed this question. Question number first. Okay. Line L1 is parallel to L2. I hope we have done this. And now the next question. Show that this relation is congruent to on the set of all triangles in a plane is an equivalence relation. Okay. So this is a very simple question. Please complete this question. I will give you 3 minutes for this. Please complete this one. Okay. And if anyone have a doubt in this, then please let me know. If anyone have a doubt, then please check here. So for every question, we need the set to which your elements belong. So here they have given the set on the set of all triangles. So the set is all the triangles. So we will let a set let S be the set of let S be the set of all triangles of all triangles. Okay, let S be the set of all triangles. Now we need to show that this relation is congruent to is an equivalence relation. Okay, so as per the question, we can write the statement only or we can show it. So first is reflexive. Okay, so we know that every triangle is congruent to itself. If you will take a same triangle, then definitely both the triangles are same. So both are congruent. So we will write every triangle is congruent to every triangle is congruent to itself. Every triangle is congruent to itself. Hence given relation is reflexive. Okay, so for the first part, we can write just a statement that every triangle is congruent to itself, hence giving relation is reflexive. Now the second one is about symmetric. Now in this case, we need two triangles. Okay, symmetric. We will assume two triangles, let T1 comma T2 belongs to S. We know that what is S? S is the set of all triangles. So let T1 comma T2 belongs to S. Okay, such that show that the relation is congruent to. So we will say here we will assume the relation as R. Let S be the set of all triangles. In the question they have not given the relation. Okay, in the question they have not given the relation. That's why we will assume the relation. We will give a symbol to a relation. So let S be the set of all triangles and R be the relation. R be the relation. What relation is congruent to? Okay, this is a very simple question. Is congruent to. Okay, so R be the relation is congruent to. Now for the symmetric, let T1 T2 comma T1 comma T2 belongs to S. That is a set of all triangles such that T1 comma T2, okay, ordered pair, this belongs to R. So we have assumed that we have two triangles which belongs to the relation R. So that means T1 is congruent. T1 is congruent to T2. Okay. So this implies T2 is congruent to T1. This is the same thing. Is congruent to T1. Okay. This implies T2 comma T1 belongs to the relation R. Hence, given relation is symmetric. Hence, given relation is symmetric. Okay, so I hope this is clear to everyone. For the symmetric, we have assumed two triangles from the set which was given, that's the set S. Okay, then we said that this ordered pair belong to the relation R. Okay, then we write over here that T1 is congruent to T2. This also means that T2 is congruent to T1. So that means T2 comma T1 belongs to the relation R. Hence, given relation is symmetric. Okay, so this is clear. Atif, Huzefa, Mazia, this is clear. Atif, Huzefa, okay, good. Good, Huzefa. Mazia, this is clear. Okay, very good. So please note down these points and then try the third one. Third is transitive. Okay. So today, hopefully, we will complete this topic relation and we'll try to start the functions. Please note down this, let me know. Then we will check for the transitive. So please try for transitive. Okay. And if you have any doubt, then let me know. I will help you in that. Okay, I hope everyone has done this. So we will start the third part. Third is transitive. Okay. Third part is transitive. So for transitive, we need three triangles. So we will write like this, let T1, comma T2, comma T3 belongs to S such that T1, comma T2 belongs to R and T2, comma T3 belongs to R. This implies T1 is congruent to T2. You can also write the symbol of congruent, it's your wish. And T2 is congruent to T3, is congruent to T3. Okay, so this implies if T1 is congruent to T2 and T2 is congruent to T3, then we can say that T1 is congruent to T3. So this implies T1, comma T3 belongs to R. Hence the given relation is transitive. Giving relation is transitive. Okay, so I hope this is clear to everyone. Please note down this, and then we will start the next question. And if anyone have a doubt in this, then please let me know. This is completed. Atif, Huzefa, Mazia. Shall we start next? Atif, Huzefa, and Mazia. This is done. Shall we start next? Okay, Mazia, good. Atif and Huzefa. Shall we start next? Okay, Huzefa. Atif, this done.
Yes.
Okay, great. Our next one. Next question is okay. Let's try this question. Show that the relation R defined on the set of all triangles in a plane as T1 is similar to T2. So this question is quite similar to what we have done already, what we have already completed. Okay. So here the relation is similar to. You need to show that this is an equivalence relation. And this is the second part. So first of all, please complete, all of you, please complete the first part. Then I will help you in the second one. Okay. First complete reflexive and confirm me on the chat box. Then start symmetric and transitive. Okay. And if anyone have a doubt, then please let me know. These are very simple question. Okay. So please complete this in 2 or 3 minutes. Atif, Huzefa, and Masia. First part is done. Reflexive.
Yes, sir.
Okay, good. Huzefa and Masia. First is done, or do I need to solve it? Okay, Masia, good. Huzefa, this is done. First part. Okay, very good. Then please try for symmetric. Okay, in the same way. And then try for transitive. Atif, Huzefa, Mazia, second part is done. Symmetric.
Yes.
Okay. Huzefa and Mazia, second part is done. Huzefa and Mazia, second one is done. Okay, Huzefa. Mazia, second part is done. Okay, very good. Please try the third part, this transitive. Okay. Okay, so transitive. Atif, Huzefa, and Mazia. Third one is done. Transitive. Okay, Huzefa, very good. Atif and
Done.
Mazia. Okay, good. Mazia, third part is done. Transitive. Okay, very good. Now the next part. They have given the three triangles. Which triangle among T1, T2, and T3 are related? So these are the sides of the triangle T1. These are the sides of triangle T2, and these are the sides of triangle T3. Anyone can tell me which of these triangles are similar? Please reply me on the chat box. Very good, Josefa. This is correct. This is correct. Very good. Atif and Mazia. Which triangles are similar? Related means similar. Here the condition is similar. Okay. So all of them are similar. No, Atif. All of them are not similar. In the previous classes, you have done some condition of similarity. In what condition we can say that the triangle is similar. Okay. So suppose if you have this triangle, please do not take the similar word, the meaning of similar word as Please do not consider this relation as you have done in English language. Similar doesn't means in maths that the shape will be same. Okay, so let this be D, E, and F. So if these two triangles are similar, ABC is similar to DEF, then that means this side will be in proportion. That means AB by DE is equal to BC by EF is equal to AC by DF. Okay, this you have done in your previous classes. So we have taken this side and we have taken this side. So AB by DE is equal to BC by EF is equal to AC by DF. If you will check in these two triangles, then if you will take T1 and T3, then please check here 3 by 6 is equal to 4 by 8 is equal to 5 by 10. Okay, that's why we will say that these two triangles are similar. That means T1 and T3. The same condition is not followed by T2. This clear? Atif, Huzefa, Mazia. Sorry, Huzefa, you have already done this. Atif and Mazia, this clear?
Yes, sir.
Okay, Mazia, this clear? Okay, very good. Okay, so you can write the language on your own. That 3 by 6 is equal to 8 by 10 is equal to, sorry, 4 by 8 is equal to 5 by 10. Okay, hence T1 and T3 are similar. Next one. Yes, there's a very good question. Let n be a positive integer. Okay, first of all, please try to understand this question. Let n be a positive integer. So everyone knows that what is an integer. Okay, and you know that what is a positive integer. So positive integer means from 1, 2, 3, and so on. Now n be a positive integer. Prove that the relation are on the set Z. Z means, anyone can tell me what this Z represent?
Integers.
Integers. Okay, so this relation is on the integers. So the set is integer on all integer numbers defined by this one. Xy belongs to R. R is the relation. And what is the relation? X minus y is divisible by n. Okay, relation is this: x minus y is divisible by n. What is n? N is a positive integer. So that means it will start from 1, 2, and so on. Is an equivalence relation on Z. So this is your question from NCERT examples. Okay, we'll try this one. First part is reflexive. Reflexive. Okay, so what is the condition? Condition is that x minus y should be divisible by n. Okay, so for reflexive, we will assume first of all one value. Let x belongs to the set. Josefa, can you tell me in this question what the set is given? Okay, no, Josefa, not correct. Okay, in every question, what we need the relation, we need the set. Okay, relation will give us the condition, and from the set we need to assume that we need to take the values. Okay, so in this case, R is not the set, R is the relation, Josefa. Okay, R is a relation. Then what is the set in this case? Integers. Very good. Let x belongs to integer. Okay, now this is the condition that x minus y is divisible by n. So we will write in this way: x minus x is equal to 0, which is 0 is divisible by any number. So x minus x is equal to 0, which is divisible by n. Okay, this implies x comma x belongs to the relation R. Okay, let x belongs to Z. X minus x is equal to 0, which is divisible by n. So this implies x comma x belongs to R. Hence relation R. Hence relation R is reflexive. Is reflexive. Okay, so I hope this is clear to everyone. So please note down this and try for symmetric. Okay. Then please try for symmetric. Then I will help you in solving this question. Okay. Please complete this one. I guess you have completed the symmetric. Okay, please check here for the symmetric part. For symmetric, we need two values. Okay, so we will assume let x comma y belongs to z such that x comma y belongs to R. If this ordered pair x comma y belongs to R, then this means x minus y is divisible by n. Okay, x minus y is divisible by n. This implies x minus y. We can write like this. If suppose we if you have a number this 16 and we are saying that this number is divisible by 8. Okay, we have a number 16 and we are saying that it is divisible by 8. Then we can write the 16 like this, 8 into some number. It can be any number. In this case, this is 2. Suppose we are saying that we have a 50 and this is divided by 25. And we can write this as 50 is equal to 25 into some number. Suppose we have 80 and we are saying that this is divisible by 8. So we can write it like this, 8 into some number. Okay, so similarly this is divisible by n, so we can say x minus y is equal to n into some number. Okay, we can write like this, n into q. Okay, and we can say q belongs to any integer. So this is clear to everyone. Huzefa, Maziha, Atif, this is clear.
Yes, sir.
Okay, Huzefa and Maziha, this is clear. Okay, Maziha, this is clear. Okay, very good. Okay, so x minus y is equal to nq. Then anyone can tell me this y minus q, what we can write? Sorry. Please change this one, x minus y. So we will say that y minus x. Anyone can tell me what we can write here? If x minus y is equal to nq, then what is y minus x? Anyone? We just need to change the sign here. Take a negative common from this, shift that to next side. So you will get minus nq. Okay, so we will write minus nq. Okay, x minus y is equal to nq, then we can say y minus x is equal to minus nq, which is also divisible by n. Okay, this number, this one minus nq is also divisible by n. So that's why we can say This implies that y minus x belongs to the relation R. Okay, this is clear to all of you. Atif, Huzefa, Mazia, this is clear.
Yes, sir.
Okay, good. Huzefa and Mazia, this is clear. Okay, Mazia, this is clear. Okay, very good. Then please note down this, and in the same way, we will try to prove the transitive. Okay, so this is quite a difficult chapter. That's why I'm trying that most of the question we will complete in class only. Okay, and after completing this chapter, we will try to solve some previous year questions. Okay, of this chapter. Everyone, please let me know once it is completed. Okay, so that we can start the third part, transitive. This is done. Atif, Zephyr, and Mazia, this is done. Shall we start next?
Yes, sir.
Okay. Zephyr and Mazia, this is done. Josefa and Mazia, this okay, Mazia, good. Josefa, this is done. Josefa, this is done. Shall we start next? Josefa, please reply on the chat box. Now for transitive, we need three values. Okay. Okay, Josefa, good. So for transitive, we need three values. Okay. So we will assume three values. Let x, comma y, comma z belongs to capital Z. Okay. This is a value which we have taken and z is the integer, such that in transitive, we always assume like this, such that x comma y belongs to the relation R and y comma z belongs to the relation R. Okay, we have assumed that. So this implies x minus y is divisible by n, is divisible by n, and y minus z, y minus z is divisible by n. Okay, because this ordered pair belong to the relation R and this ordered pair y comma z belongs to the relation R. That's why we will say that x minus y is divisible by n and y minus z is divisible by n. Now in the previous case, we have written this like this: x minus y is equal to nq. Similarly, this also can be written like this: y minus z is equal to n into, because we are saying that this is divisible by n. That's why we can write like this: n into, you can take any other variable. Let's suppose p. Okay, where what is p and q? P and q are integer. P and q belongs to the integer set. Now, let this be 1. Okay, let this be 2. Add 1 and 2. Add 1 and 2. Okay, so you will get what? Add this: x minus y plus y minus z is equal to nq plus np. So from this, y will cancel out and we will get x minus z, which is equal to, now from this you can take n common, so you will get what? Q plus p. Now anyone can tell me that this expression is divisible by n or not?
It is divisible.
It is divisible. Okay, because n is getting multiplied with this complete bracket, like this be third. So we can say, uh, just give me a minute, which is divisible by which is divisible by n. Okay, this implies x comma z belongs to the relation R. Okay, so we can say hence given relation is transitive. Given relation is transitive. Is transitive. Okay, so there are some chapters which will take a long time. Okay, for example, this one, relation and function. There are some chapters which we can complete in the 2 classes. For example, inverse trigonometric functions. Okay, inverse is a simple chapter. So we will try to complete that in 2 classes, but we need a lot of time for this chapter. Okay, so please note down this, confirm me, then we will start next question. Okay. Hello, Iba. You were in the waiting room. That's why I pull you in this crowd. This is maths class of class 12th. Okay, so I guess you have joined the wrong class. Okay, Iba. You have joined for which class? Okay, so please let me know if this is done. Josefa, Atif, and Masir. Okay, Masir, good. Okay, Josefa. Atif, this is done. Shall we start next?
Yes, sir.
Okay, very good. Okay, this is a very good question. Here, this is the relation. Okay, show that the relation on the set A. This set is given. Okay, this is the set given by this relation. Relation is what? Modulus of A minus B is even. Okay, so you need to find the difference. You need to find the mod is even, is an equivalence relation. And from which set you need to select the values? You need to select the values from this one. Okay, and this is the second part. There's a second part which I will help you in solving this. So please try this. Try for first reflexive, symmetric, and transitive. Okay, and this is a very good question. This already came in CBSE 2009. Okay, please try this. Okay, so I hope everyone has done this. The first part. First, you have to do in the same way as you have done the previous question, reflexive. Okay, so first of all, we will assume a value. Let a small a belongs to. Okay, Josefa, can you tell me to which set this element belonged? A. Zephyr, can you tell me to which set this element belong? A, small a. Yeah, very good. This is a set A. So let A belongs to set A. Now A minus B. Okay, we will write this A minus A modulus. So we'll get a 0. 0 is an even number, which is even. Hence, A comma A belongs to the relation R. So relation R is reflexive. Is reflexive. Okay, this is clear. Atif, Huzaifa, and Masih, this is clear.
Yes, sir.
Okay, good. Huzaifa and Masih, this clear. Okay, Masih, good. Okay, Huzaifa, very good. Okay, so this was the first part. Now, in the same way, please try for the second part. Second is symmetric. Now, here we need two values. Okay, symmetric. Let we need two values, so A comma B. Let A comma B belongs to the set A such that ordered pair A comma B belongs to R. This implies modulus A minus B is even. Okay, because we have assumed that this belongs to the relation R. That's why we are saying that this modulus A minus B is even. Okay, so this also means that if you will find the modulus of B minus A, which this is also even. Okay, you have the modulus. If you will interchange these one and there is a change of sign, then modulus will convert that sign into a positive value. So if A minus B is even, then B minus A is also even. This implies B comma A belongs to the relation R. Hence relation R is symmetric. Okay, this clear? Atif, Huzaifa, and Masih. Atif, Huzaifa, and Masih, this clear?
Yes, sir.
Okay. Huzaifa, Masih, this clear? Okay, Masih, good. Huzaifa? Okay, very good. Please note down this, then we will do the transitive. Okay, Atif, in your school, which chapter is going on?
So right now, determinants and applications of derivatives.
Determinants and application. Okay, so they have completed relations, inverse, and matrices.
No, sir, they're not going by order. They haven't completed relations.
So which chapters they have completed?
They have completed matrices, then
Okay.
continuity and differentiability.
Okay, continuity, differentiability, they have completed complete differentiation.
Yes, sir. Complete full chapter complete.
Full chapter. Okay, and when you have your next exams?
Next exam, next week, June 15, 16. Yeah, somewhere in those
June
weeks.
15, 16. And what's the syllabus?
Syllabus they haven't announced yet.
Oh, okay.
Most probably, I think full continuity differentiability matrices. I think full chapter will come.
Matrices, determinants first. Oh, okay. And Huzaifa, which chapter is going on?
Continuity and differentiability.
Okay, so they have completed the relation, inverse, matrices, determinants.
Yes, sir, all four done.
All four are okay. And when you have your exams?
Around 18th, I think.
18 June.
Yeah.
And the syllabus will be complete up to continuity and differentiability.
Yes, sir.
Okay.
For the first four chapters, not continuity and differentiability.
Okay. Then it will be possible for us to complete inverse also till 18th. Today is fourth one. Yes, we can. Okay, Mazia, in your school, which chapters are going on? Inverse. Okay. And then how many chapters they have completed? Relations. 4 chapters. Okay. Fourth means relation, inverse, matrices, determinants. Okay. And when you have your next exams, Monsieur? Next Sunday. Okay. Okay. Good. Okay. So I hope everyone has done this. Shall we start next one? Next is what? Next is about the transitive. Okay. Third part. Third is transitive. Now, in transitive, what we will do, we will assume 3 values. Let A, comma B, comma C belongs to the relation R. Okay, such that, sorry, not R, belongs to the relation A. Belongs to the relation A such that A, comma B belongs to the relation R and B, comma C belongs to the relation R. This implies, okay, now if you will check the previous case, then here we have this AB is given. Such, so this implies A minus B is even and B minus C is even. Okay, now A minus B is even when at the, you'll write here A minus B is even when A B when A B both are odd or both are even. Okay, we are saying the difference of two numbers is even, so we will take example. For example, we have 1 and 3, both are odd number. If you will subtract two odd number, then you will get a even number. Similarly, if we are taking 2 and 4, so both are even numbers. So if you will subtract two even number, then you will get an even number. Okay, so what is the condition? Two subtraction of two number is even when either both are odd or both are even. The same thing which we have written here. Okay, next we will check B minus C. Okay, the same condition is for B minus C. The same condition is for B minus C. In the bracket, we will write modulus B minus C is even when A, comma B both are odd by A, B minus C. Okay, so B, comma C both are odd or both are even. Both are even. Okay. Now we will solve this by taking two cases. Case one, when B is odd. Okay, we have break down this in two cases. When B is odd, A minus B and B minus C are even. We have assumed that one value is odd, B is odd, and this is given that A minus B and B minus C are even. So we can say, anyone can tell me if B is odd, then what will be the value of A and C? A and C will be even or odd? In this case, A and C is
Odd.
odd. Very good. Okay, when B is odd, and we have here we have written that A minus B and B minus C are even. So when they will be even, when B is odd and these are even, this implies A and C are odd. Now A and C are odd, then A minus C, Josefa, if both value A and C are odd, then can you tell me what is modulus A minus C? This will be even or odd? Even. Very good. Modulus A minus C is even. This implies A comma C belongs to the relation R. Okay, so we have divided this into two cases. First, when B is odd, and case 2, we will take when B is even. The same steps we will write in the second case. Okay, so please note down this complete one. Then we will do the last case and then this is over. Okay, please complete this. Let me know, then we will start the next case. Today we need to start functions also. So I will give you some questions in homework, okay, from this PPT. Please let me know if this is done. Then we will start next. This is done. Atif, Huzefa, and Mazia. Shall we start next?
Yes, sir.
Okay. Huzefa and Mazia, this is done. Shall we start next? Huzefa and Mazia. Shall we start next? Okay, Mazia. Atif. Sorry, Huzefa. Okay, Huzefa, good. So I need some space. So I'm raising the bar. Okay, when B is even. Okay, so the same steps will repeat here. Modulus A minus B and modulus B minus C are even. This is given. Okay, so this means A and C are what? A and C are even or odd?
Even.
Even, because B is even and we are saying that A minus B is even. So that means A and C should also be even, because the subtraction of two even number is a even number. A and C are even. Okay, if A and C are even, then their subtraction will also be even. Will be an A minus C is even. This implies A comma C belongs to the relation R. Hence, relation R is transitive. Is transitive. Okay. So the biggest challenge in this chapter is how to represent your answer. Okay. In the starting of the question, you already know that this is reflexive, symmetric, and transitive. But how to represent your answer, that is the main task. Okay. Please note down this. We will try. Okay. There's a second part in this question. So please check that. First of all, note down this, confirm me, then we will check the second part. Okay. This is done. Adif, Huzefa, and Mazia, this is completed. Shall we start next?
Yes.
Okay. Huzefa and Mazia, this is done. Shall we start next? Okay, Mazia, good. Huzefa, this is done. Okay, Huzefa, very good. Now, okay, so the next part is show that all the elements of 135 are related to each other. They are saying that 135 will be related to each other. That means one will be related with 3, one will be related with 5, one will be related with 1, and 2, 4 are related to each other. But no element of 135 is related to any element of 2, 4. First of all, anyone can tell me that this statement is true or false? This statement that 135 will be related with 135 only and 24 will be related with 24 only. So this statement is true or false?
True.
True. Okay, because 135 are the odd numbers. So we know that the difference of odd number is a even number. Similarly, 2, 4 are even number. That's why the difference of even number is a even number. So as per this condition, if you will subtract two numbers, the result should be a even number. So that's why that's why odd number will be related to itself. Sorry, all odd numbers will be related with each other and even number will be related with each other. So we will write this statement: difference of odd number difference of odd number is a even number. Is a even number. Hence 135 are related 135 are related to each other. Okay. Similarly, we can say that difference of even number is a even number. Hence 2, 4 are related to each other. Okay. So I hope this is clear to everyone. Please note down this, confirm me. Then we will do one more question. Then rest of the question are homework. Then we will start the functions. Okay. Please note down this one. This is done. Atif, Huzefa, Mazia, this is done. Atif, Huzefa, and
Yes, sir.
Mazia. Okay, Atif, Huzefa, and Mazia, this is done. Okay, Mazia, very good. Huzefa, this is done. Shall we start next? Okay, Huzefa, very good. Okay, now this is the next question. Okay, this is a very important question. You can see here that this question came 3 times in CBSE 2010, then 2018 and 2019, and this question is also there in your NCERT. Okay, first of all, we need to show that this relation R on the set A is given by, this is the set A. So anyone can tell me the values of this set A? Anyone can tell me the values of set A?
Sorry, sir.
What are the values of set A? Can anyone tell me? This is written in the set builder form. So anyone can tell me in roster form. X belongs to integer and X is from 0 to 12.
0, 1, 2, 3, 4, 5, 6 until 12.
Very good. So I hope this is clear to everyone. Because in the question it is written that this is integer and it is start from 0 and up to 12. So 0, 1, 2, 3 and up to 12. Okay. Now given by relation R is equal to A minus B, which is a multiple of 4. So they're saying that A minus B is a multiple of 4 is an equivalence relation, and then they are saying find the set of elements related to 1, that is equivalence class 1. Now equivalence class is a new concept for you. Okay, so we will discuss this equivalence class later on. First of all, we need to prove that this is equivalence relation. Okay, multiple of 4, so please show this as a reflexive, symmetric and transitive. Okay, so we have done a similar type of question here. I will show you this one. Here they are saying that this is divisible by n, and in this question they are saying it is a multiple of 4. So both the questions are somewhat similar. So please try to complete this and let me know if you have any doubt. And this is a very, very important question. Okay, then I will help you to solving this equivalence class. First of all, please complete the reflexive and let me know that. Okay, after that we will start next. This is done. Atif, Josefa, and Mazia, the first part, reflexive.
Yes, sir.
Okay, great. Josefa and Mazia, the first part is done, reflexive. Josefa, Mazia, the first part, reflexive. Okay, so for reflexive, first of all, we will assume a value. Let A belongs to set A. Now A minus B is a multiple of 4. So we will show here that A minus A is equal to 0, which is a multiple of 4, which is a multiple of 4, which is a multiple of 4. Okay. Now, so this means A comma A belongs to the relation R. Okay, A belongs to the set A. So we are saying that A minus A is a 0, which is a multiple of 4. So that means this belongs to the relation R. Hence the given relation is, reflexive. Okay. Now second part. Second is symmetric. So now here we will assume two values. Let a comma b belongs to the set A such that a comma b belongs to R. We will assume this. So we will write what is the meaning of this. This means a minus b is a multiple of 4. Is a multiple of 4. Then same thing, we can say that a minus b, we can write it's a multiple of 4. Okay, so we can write a minus modulus a minus b. This is equal to 4 into, we can write any value q. Okay, now here this value we will select from this one. So we can say that q belongs to z plus. Okay, positive integer. Because if you will take a negative integer, this become minus 4, and so that is not correct. Now next one. So this implies modulus of b minus a. This will remain the same, 4q. Hence modulus of b minus a is a multiple of 4. Is a multiple of 4. Hence b comma a belongs to the relation R. So relation R is symmetric. Okay. Now please note down this, confirm me, then we will start the transitive. And if anyone have a doubt, then please let me know. So this is done. Atif, Huzaifa, and Mazia. There are some questions which are very difficult. It is one of them. This done. Atif, Huzaifa, and Mazia. Shall we start next?
Yes, sir.
Okay. Huzaifa and Mazia, this done. Shall we start next? Okay, very, very good. Now next one. Third part. Okay, third is transitive. Transitive. So we will assume three values. Let a, comma b, comma c belongs to the previous set. Set is a. Okay, so belongs to set a, such that a comma b belongs to the relation R, and b comma c belongs to the relation R. Okay, so this implies a minus b is a multiple of 4, and modulus b minus c is a multiple of 4. Is a multiple of 4. Okay, so we can say here that a minus b, we will assume that it is a multiple of 4, so we can write 4q as we have done in the previous question, and modulus of b minus c is equal to 4. We can take any other variable, for example p. And what are p and q? We can say that they belongs to the positive integer. Okay, now if you will remove the mod, so always remember, whenever you will remove the mod, on the right side you will get a 2 sign, plus minus. Similarly here, let this be 1. Similarly here, if you will remove the mod, on the right side we will get plus minus sign. Let this be 2. So add 1 into add 1 and 2. So here we will get a minus b plus b minus c is equal to plus minus 4q plus minus 4p. So b will cancel out here. We will get a minus c, which is equal to, you can take a 4 common. Okay. And here you will get a plus minus q plus minus. So this subtraction of a minus b is equal to 4 times of this one. So that means if you will take a modulus of a minus c, then it is divisible by 4. Then modulus of a minus c, we can say it is a multiple of 4, because this expression can be divided with 4. So we can say here that this is a multiple of 4. This implies a comma c belongs to the relation R. Hence relation R is transitive. Okay. So we have proof here that the relation R is transitive. So please note down this. Then we will check the third part, which is the second part, which is important. That is the equivalence class. Okay. Okay, Atif, Zephyr, and Mazia, this is done. Shall we start next? Atif,
Yes, sir.
Huzaifa. Okay. Huzaifa and Mazia, this is done. Huzaifa and Mazia, this is done. Okay, Mazia, good. Huzaifa. Huzaifa, shall we start next? Okay, good. Now please check the next part. Next is, they are saying, find the set of all elements related to one that is equivalence class 1. Okay, first of all, write the definition of this equivalence class. Equivalence class class 1 is the set of all those elements from set A which are related to this one under the relation R. Okay. So what is mean by equivalence class? Equivalent class means all those elements from this. First of all, we'll write the set here. This is from 0, 1, 2 up to 12. Okay. So in this set, what is mean by equivalence class? All the values which are related with 1 under this condition. Okay. All the values which are related with 1 under this condition. What is the condition? That subtraction of two numbers should be a multiple of 4. So that means one number is 1. You need to select the second number and so on, and all the numbers. Whenever you will subtract the two numbers, this will be a multiple of 4. Okay. So we will try to solve this directly. Equivalence class 1 is equal to. So anyone can tell me the first number?
1.
1, good. Because whenever you will subtract 1 and 1, you will get a 0. Okay. And 0 is a multiple of 4. Next number?
5.
Good, 5. Because if you will subtract this 5 minus 1, you will get a 4, which is a multiple of 4. What is the next number?
9.
9, very good. Next is 9 minus 1 will give you 8, which is a multiple of 4. Just a minute, Atif. Josefa, can you tell me the next number? 13. Okay, 13 is not there. Okay, in this set, we will take the value from 0 to this. Okay, so that means the final solution is 1, 5, and 9. This is clear to all of you. Atif, Huzefa, and Mazia, this clear?
Yes, sir.
Okay, so what is mean by equivalence class? Equivalence class means that one number is given, you need to find the second number which will satisfy the relation, or we can say which follow that relation. So here the relation is subtraction of two number. So you need to select the next number whenever you will subtract them, that will be a multiple of 4. Okay, so most of the time they ask about this equivalence class. Okay. Okay, so Josefa, Mazia, this is clear. Josefa and Mazia, this is clear. Okay, Mazia, very good. Josefa, this is clear. Josefa. Josefa, please confirm. And please note down this. Now we will start the functions. The rest of the question you need to do in the homework. Okay, so we have right now 40 minutes. So I will give you the homework, and after that we will start the functions. Okay, Josefa, I hope you have completed this. So we are starting the next one. So okay, this question is from NCRT, so you need to solve it. Okay, please note down this question and just give me a minute. I need to check how many questions. 2, 3, 4, 5. Okay, so you need to do in homework 5 questions. Please note down this. Okay, and these are important questions because they are from NCRT or from the previous year questions. So please solve it. And if you have any doubt in this, then we will discuss these questions tomorrow. Okay, please note down this question and confirm me one by one. Then I will show you the next question. This is done. Atif, Josefa, Mazia, this is done. Atif, Josefa, and Mazia, this is done. Shall we start next? Okay, Mazia. Okay, Josefa, shall we start next? Okay, very good. Okay, so this is question 1, but tomorrow I will discuss about these questions. Okay, so we have 5 questions. Please try to do all these. And if you have doubt in all these questions, then we will discuss this again. Okay, because we don't
Can
have
we go to the previous question?
Yeah, because we don't have so much of time today to complete this one.
Okay.
Okay, good. Next, this one. Again, same, you need to prove that it's an equivalence relation and you need to find the equivalence class. This question came in CBSE 2010. Okay, so we can say this is an important question.
Sir, equivalence class 2, 3 means we have to find the set of all the elements related to 2 and 3.
Yes, and 1 and 3.
Okay.
Now, in this case, what happened? Normally, we have two elements, A related with B. But here, in place of element, they have assumed the ordered pair. So this is the difference. Here, the first
Okay, sir.
element, okay, in the place of first element, you have first ordered pair. This is second one. Okay. Please confirm if this is done. I will change the slide. This is done. Atif, Zafar, Mazia is complete.
Yes, sir.
Okay, okay, Mazia. Zafar, this done. Okay, very good. Now next, there's a third question. Okay. Again, you need to show that there's an equivalence relation and obtain the equivalence class. So you can see this question again came in CBSE 2014. So equivalence class type of questions are very important. This is done. Atif, Zafar, Mazia is completed. Atif,
1
Zafar.
minute, sir.
Okay. Zafar and Mazia, please confirm. Okay, Mazia, good. Zafar, this
No, sir.
time. Okay. Zafar, okay, great. Now next one. Okay. Again, you need to prove that it's an equivalence relation. This question came in CBSE 2015. Okay. So there's also a very good question. Shall we start next? This one. Atif, Huzaifa, and Masir this time.
Yes, sir.
Okay. Huzaifa and Masir this time. Zephyr and Mazia this time. Shall we start next? Zephyr, please try all these questions, okay? And tomorrow we will discuss this question if you have any doubt in all these 5 questions, okay? But please try to solve this on your own. We will discuss this tomorrow, okay? Okay, so Zephyr, this time, shall we start next? Okay, this is the last question, okay? Again, this question came in CBSE 2014, and you can see here that again they ask about the equivalence class. So in relation, this is a very important topic, equivalence class.
Sir, first you have to prove the relation is an equivalence relation, right?
Yes, first you need to prove that is a equivalence relation. Okay, so shall we start next? Atif, Huzaifa, and Mazia? Huzaifa, Mazia, and Atif, shall we start next?
Yes, sir.
Okay, Huzaifa and Masir, shall we start next? Okay, Masir, good. Okay, Huzaifa. So we just have 25 minutes. Okay, so today we will just discuss about the definitions, and tomorrow we will try to solve questions on functions. Okay, first thing, what is a function? You have done this in class 11. So any idea? Just yes or no? Okay, otherwise I will explain this to you. What is a function? No? Okay, not a issue. Please check here. Let A and B be two non-empty sets. Okay, you know about what is a non-empty set. So we have two sets A and B which are non-empty. Then a function f from set A to set B. It is a rule or method which associates elements of set A to elements of set B such that. So it is better if I will represent this to you by a arrow diagram. Okay. Now suppose we have a relation. What is a relation? What is a relation?
Subset of A cross.
Subset of Cartesian product. Okay, so relation drive from the Cartesian product. Functions will drive from the relation. So suppose we have a relation like this, A comma B, or we can say like this. From the next class, we will take a 5-minute break. Okay, I forgot today, but from the next class, we will take a break. Suppose we have this relation that 1 comma 2, 3 comma 4, 5 comma 6, 7 comma 8. Suppose we have this relation. Okay, then this relation can also be represented by the arrow diagram. What is the arrow diagram? We will represent a set like this, you already know that how we form a relation from the Cartesian product of A and B. So we have two sets. So we can represent these two sets like this. This is set A and this is set B. Okay, this is the arrow diagram. In set A, we will write the values of A. So here the relation is 1, this. So we know that this first element will belong to the first set. So we will write 1, 3, 5, and 7 here. We know that the second value 2, 4, 6, and 8 just slide to the second set. 2, 4, 6, and 8. Now here in this form, we have related 1 with 2. In arrow diagram, what we can do, we can mark the arrow that 1 is associated with 2. We'll write like this. 3 is associated with 4. I hope you have done this in class 11. Okay. This arrow diagram was there in class 11, 7, 8. So by arrow diagram, we can represent this relation like this. Okay. This is clear to everyone. We have not started the function yet, but I just want to make sure that you understand what's the arrow diagram, because in this topic, we will use the arrow diagram. It is easy to analyze the ordered pair from the arrow diagram. So this is clear. Atif, Huzaifa, Mazia. Atif, Huzaifa, and Mazia. This is clear.
Yes, sir.
Okay. Huzaifa and Mazia, this arrow diagram is clear. Because we will understand. Okay, Huzaifa. Because we will understand this concept of function from the arrow diagram. Okay, Mazia, very good. Okay, so this was the arrow diagram. Now we will discuss that what is a function. Now we will form a set. We will write like this. This is set A, and we will form the next set, which is B. This is set B. Okay, we have this one 1, 2, 3, 4, 5, and suppose in set B we have these values 6, 7, 8, 9, 10, 11. Okay, now what is a function? It is a type of relation. Okay, it is a type of relation, or we can say it is a rule which associates the elements which are present in set A to set B. Okay, and what is the condition? There are two conditions in functions. Okay, please remember the two conditions. First is all the elements which are present in set A should be related to the elements of set B. All the elements which are present in set A should be related to the elements of set B, or we can say which will be associated to elements of set B. So this is the same thing. Okay, so we are saying that all the elements, if this is a function from A to B, if this is a function from A to B, then the first condition is all the elements which are there in the set A should be related to the elements of set B. So that means 1 should be related with 6. For example, this can be related with any value. So what they are saying that all the elements should be related to some elements of set B. Even like this. Even like this. Even like this. So first of all, we are focusing on set A, that all the elements which are present in set A are associated to elements of set B. So just focus on set A. Just give me a minute. Sorry. Okay, so I hope the first part is clear to everyone. Okay, so this is the first part. So what does that mean? That means suppose we have a set A and we have a set B. Okay, here we have a value 1, 2, 3, and here suppose we have a value 4, 5, 6, and 7. So 1 is related with 4, 2 is related with 5, and 3 is blank. 3 is not related with anyone. 3 is not associated with anyone. So this can't be a function. So our first condition is all the elements should be associated, should be related to the elements of set B. I hope this is clear to you. If anyone have a doubt, then please let me know, because I will ask question from this again. This was the first condition. I will write here first one. Okay. Second condition. What is the second condition? All the elements of set A should related to unique element of set B. What does this mean by unique element of set B? Suppose we have a set A here. We have a set B here. Suppose this is 1, 2, 3, 4, and here we have 5, 6, 7, 8, 9. So unique element means one will be associated with only a single element. For example, in here, 1 is associated with 4. Now, 3 will be associated with 7. Okay, so first condition is satisfied. But if 1 will be associated with 5 also, 1 is associated with 4, 1 is associated with 5. So in that case, this is not a function. Because as per the second condition, the value of A, the elements of A should associate to a unique element of set B. So 1 should be associated with only one value. Similarly, 2 will associate with only one value. This is possible that 3 can be associated with 6, but 3 should also associate with a single value. For example, 4 can also associate with 6. This is or 7. This is a function. Okay, so this is the second condition, that all the elements which are present in set A should be associated to unique element. They should be linked to a single element only. For example, 1 is linked with a single element 5. If you will check this example, here 1 is linked with 2 elements. That's why this is not a function. So always learn the definition of function in 2 steps. In different books, they have a different method of representation, but please remember the definition in 2 steps so that you will not do the mistake. What is the second condition? They should associate to a unique element. What is the first condition? All the elements which are present in set A should associate to elements of set B. So the first condition say that all the elements should be associated to elements of set B. So that means there should not be any element which will not be linked with any other element of set B. This is the first condition. Second condition says that this should link to a unique value. Okay, so I hope this is clear to everyone and we still have some time. So I will ask some questions from you. This question is from Mazia. Mazia, this is set A and this is set B. Okay, here we have the value 1, 2, 3, and 4. And here we have the value 5 and 6. So, okay, so now Josefa, this question is from you, 5, 6, 7, 8. Okay, 1 is associated with 5, 2 with 6, 3 with 7. So Josefa, can you tell me this is a function or not? No, very good. Okay, Josefa, now can you tell me this is a function or not? No, no, why? What is the reason, Josefa? No, unique means the elements of set A should not be linked with 2 elements. That means 3 should not be linked with 2 elements. But here we will see 3 is linked with a single element. Similarly, 4 is linked with a single element. Unique means this should not be the case. This is A, this is B. So this is 1, 2, 3, 4, 5, 6. So if 3 is linked with 5 and 3 is also linked with 6, then this is not unique. Okay, but this is a function because 3 is related with a single element, 4 is related with a single element. This clear, Josefa? So this is a function. Okay, Josefa, one more question. This is set A and this is set B. Okay, this is 1, 2, 3, 4. Here we have 5, 6, 7. 1 is related with 5, 2 is related with 5, 3 is related with 5, and 4 is related with 5. So Josefa, can you tell me that this is a function or not? Yes, it is a function. We will check the first condition. All the elements of set A are associated. Yes. They associate to a unique element. Yes. That's why this is a function. Okay, Atif, this is clear?
Yes, sir.
Okay, so this is a function. This is also a function. I will remove this one. Okay, so please note down. Okay, then we will again check this definition. I will remove this. Okay. So the definition is let A and B be 2 non-empty sets. You know this. Then a function F, function is represented by F, as normally relation is represented by R. So function is represented by F. Then a function F from set A to set B is a rule or a method which associates elements of set A to elements of set B such that the first condition is all elements of set A are associated to elements of set B. This we have discussed. What is the second statement? An element of set A is associated to a unique element in set B. Okay, so that means one should not be linked with two elements. So I hope this is clear to everyone. Please note down this definition, confirm me, then we will start the next topic. Okay.
Sir, so function is basically a special kind of relation, right?
Yes, Atif, it's a special kind of relation. Okay.
Okay.
So this is a complete chain, Cartesian product. Then from Cartesian product, we will get a relation. From the relation, we will get a function. So this is done, Atif and Huzefa. So as an example, if you want to note by arrow diagram, you can take the values like this. This is A, this is B. Okay, this is A. This is 1, 2, 3. This is 4, 5, 6. So you can relate like this, and this. So this is a function. Very simple example. Okay, so shall we start next, Atif, Huzefa this time? Atif and Huzefa.
Yes, sir.
Okay, Huzefa, shall we start next?
Yes, sir.
Okay, great. Next one. Okay. If an element A belongs to A is associated to element B belongs to B, then B is called the image of A under F. Okay, so what does this mean? Suppose we have a set A, we have a set B. Okay, and we will write here 1, 2, 3. Here we will write 4, 5, 6. 1 is related with 4, 2 with 5, 3 with 6. Now A belongs to A, and one that this number 1 is there in set A, this number 4 is there in set B. 1 is associated with 4, then this 4 is called the image of A. We will simply call 4 is the image of 1. 4 is the image of 1. Similarly, 5 is the image of 2. Similarly, 6 is the image of 3. Okay, so if an element A belongs to A is associated to element B belongs to B, then B is called the image of A under F. And then what this A is called the pre-image of B. Okay, B is called the image and A is called the pre-image of B under the function F. Okay, so you have done, I hope you have done this in class 11th also. So this is clear, Atif and Huzefa, this is clear?
Yes, sir.
Okay, Huzefa, this is clear? So we still have 10 minutes, okay? So we will try to complete as much as possible in this 10 minutes because we need to complete a syllabus on time. Okay, so please note down this. I will give you 1 minute for this. Then we will start the next topic. Okay, so what we will do today, it is not possible to start the topic of class 12, but we will revise all the topics which are there in class 11. Okay, so I hope everyone has completed this. So we will start the next topic. Domain, codomain, and range of the function. Okay, so this also you might have, this also you have done in class 11, that what is a domain, what is a codomain, and range. Always remember, for example, in the previous slide, we have shown set A like this, set B like this, okay? So this is a function, we are talking about the function. So we will write this symbol, F is a function from A to B. What does that mean? That means first set is A, second set is B, and elements of set A are associated to set B by this function. So we will read this as f is a function from A to B. Okay. Now, domain, codomain, and range of the function. So first of all, f is a function from A to B. Okay. So I hope now this is clear to you that what is meant by this. F is a function from A to B. So the first value is present in set A, second value is present in set B. Set A values are associated with the values of set B. Okay, then the set A is known as the domain of F. What is the domain of the function? If we have two sets, we will take example again. Suppose this is A, this is B. Here we have the value 1, 2, 3. Here we have the value 4, 5, 6. 1 related with 4, 2 with 5, 3 with 6. Then we will say the complete set A is the domain of F. So Josefa, can you tell me for this example, what is the domain? Josefa, in this example, what is the domain? Josefa, what is the domain here? Josefa, are you there? Josefa, yes. Oh, okay. Josefa, so as per the definition, please check here. If f is a function from A to B, we have these two sets. So this is a function from A to B. Then this complete set A is known as the domain of F. So what is the domain? The complete set A. So that means 1, 2, 3. This is the domain of F. So this you have done in class 11. This clear, Josefa, now? Okay, so 2 times yes is written. So I hope Josefa this is clear. Now, what is set B? Set B is called the codomain. Okay, so if in exam they will ask you that what is the domain and the codomain, then complete set A is the domain, complete set B is the codomain. Okay, so this 4, 5, 6 value, this is the codomain. Now, what is the range? The set of all F images of element A is known as the range of F under F. So what does this mean? This is 6, suppose this is 7. Now, Josefa, please reply me, what is the codomain in this case? If this is a function from A to B, Josefa, then what is the codomain? No. Oh, okay, sorry. This is correct. 4, 5, 6, 7. Okay. So complete set B is the codomain. What is the range? Range is, what is range? Range is set of all F images of elements of A is known as a range of F. So that means the images of these elements 1, 2, 3. What is the image of 1? 4. What is the image of 2? 5. What is the image of 3? 6. So the image of 1, 2, and 3 is called the range. So range is 4, 5, 6, but the codomain is what? 4, 5, 4, 5, 6, and 7. Okay, Atif and Huzefa. This is clear.
Yes.
Okay, Huzefa, this is clear. Okay, very good. Then please note down these definitions. Okay, so we have done the part of class 11. Tomorrow we will start the kind of function, that is the topic of class 12th. Okay, but please complete that 5 questions which I have given you today from the relation function. Those are very, very important questions. Okay, so tomorrow, first of all, I will check if you have any doubt in those 5 questions. We will solve them first, then we will start the kinds of function. Okay, so please note down this, then we can end up the class. Okay, so if you have done this, then it's your wish, you can drop off. We will end the class now. Atif, this done? Atif, this done?
Yes, sir.
Okay, Atif, good. Josefa, this done? Okay, very good. So thank you so much. We will continue this topic tomorrow. Okay. Okay. Bye-bye.
Thank you, sir.
Okay, you're welcome.